Okay, let's talk about how you go about figuring out oxidation and reduction. So, in order to be able to handle questions such as these oxidation reduction practice questions, you needed to first know what oxidation and reduction is, because these sorts of questions are the sort of thing, well, you'll see on the test. And what you'll have to figure out is, like, if you look at this right here, let's say, you have to figure out which one's being oxidized, which one's being reduced. Okay, well, in order to do that, first you need to be on top of what oxidation and reduction even is. So, let's go back to the basics of what it even means. Okay, oxidation and reduction in terms of chemistry. Whether you have heard of it or not, it is actually at the core of many chemical reactions. Even something as simple as lighting something on fire, it revolves around oxidation and reduction. Now, in chemistry, here is the definition: oxidation and reduction. Okay, oxidation is loss of electrons. Reduction is gain of electrons. I know, it sounds like opposites, right? Reduction means gaining electrons. Well, there's reasons behind it, but that's the definition. So to help people remember that, I gave you guys a note handout some time ago, which, here you go, trying to get hold of it, had this cute little picture on it. And this is a nice little way to remember what oxidation and reduction means. Okay, put this cute little cartoon on there. Leo says grr, where LEO means loss of electrons is oxidation, gain of electrons is reduction. So there's a little explanation right down there. Okay, so maybe that'll help you. Leo says grr. Or sometimes people just remember by looking at this little bit. Reduction means gaining electrons because it's kind of a weird opposite sort of thing. And well, I guess if you remember what reduction means, then you can figure out what oxidation means. It's the opposite of that. Everybody's different. Everybody remembers things differently. So hey, if remembering that the reduction thing is an opposite, then that works for you, then awesome. And if Leo says grr works for you, then use that to keep it straight, what oxidation is and what reduction is. Okay, so that being said, let's look at the process of identifying what's being oxidized and what's being reduced. Remembering that reduction means gaining electrons and oxidization means losing electrons. So if you have, say, this hydrogen plus oxygen makes water, here's what you're going to do. You're going to start by saying that a pure element has no charge, which means H starts out, H2, the hydrogens have a charge of 0. Oxygen, you're going to say, has a charge of 0 when it's just pure oxygen. When it's part of a compound, no longer are these neutral. Looking at the periodic table, you look at hydrogen. Hydrogen is a +1. That's a +1 charge, okay? What about the oxygen? The oxygen is a -2. And this is why there's 2 hydrogens needed to balance out the 1 oxygen. Okay, so, let's think about that. What does this tell us? What happened here? Alright, well, what happened here is that hydrogen basically went from having no charge at all to having a +1. Basically, this happened during the course of that reaction. Well, how does it get from H to H+? You have to think, did it gain or lose electrons? Well, a hydrogen atom starts out as being a proton and a neutron. That's a hydrogen atom. How do you make it positive? And sorry, I just realized I said proton and neutron. Proton and electron. Okay, so anyway, how do you get from being neutral, where you have a proton and an electron and they're balanced, how do you get from that to being H+? Well, you have to lose an electron, right? If you lose the electron, as in, okay, that little minus is gone now, all you have left is that plus. So in order for this to happen, you had to lose, I just misspelled lose, but you had to lose an electron. And then back to this right here, loss of an electron, that's oxidation. Okay, loss of an electron is oxidation. So we would say hydrogen got oxidized. Okay? So we're going to say this got oxidized. Now, process of elimination, if one got oxidized, the other got reduced. But let's look at why. Okay, what's really important here is to understand why we know that oxygen got reduced. So, actually, let me bring it back up here, because look at what happened to oxygen. It started as neutral oxygen, and it turned into oxygen with a 2- charge. So, let's bring up some a blank work area here. So, okay, for oxygen. It started as oxygen, and then it turned into oxygen with a 2- charge. So originally, the oxygen had a balance of protons and neutrons, giving it neutrality. Oops. Yeah, whatever. Okay. Made a little mistake here, so I had to scribble it out. But either way, you get the idea. It had the same number of protons and neutrons. I know oxygen should have 8 neutrons, and 8 protons, and 8 electrons, and whatever, but you get the idea. Neutral oxygen has a balanced number. In order for oxygen to be a 2-, you'd have to add on a couple of extra electrons in order to give it that extra minus charge. So, in order to go from neutral to negative, it had to gain electrons. Okay, that's gain of electrons, and once again, going back to our little lion cartoon, gain of electrons is reduction. That's the grr of Leo says grr. So, reduction. Okay, so that's the overall view right there. So when the oxygen went to being oxygen 2-, it gained electrons, that's reduction. So that's why I'm going to say that oxygen was reduced. Okay, as you can see there. Okay, so aside from process of elimination, that's the other way you figure it out. Okay, because it is important to be able to understand both ways around. Alright, let's look at another example. Number 2 on this worksheet is this one with the iron and the zinc chloride. Okay, well, figuring out what to do with the iron and the zinc chloride. So let's see what's really happening here. Let's break it down into each of these individual things. I'm going to write it a slightly different way from here. The iron starts out as just neutral iron. And then what form does the iron have at the end? Let's look here. Iron and then 3 chlorines. Well, if each chlorine's a minus and there's 3 of them, then the iron must have a 3+ charge. The iron's got to have a charge of 3 in order to bind with 3 chlorines. And I know that iron is a 3+ because iron's a metal and all metals have a positive charge. So from here to here, iron went from neutral to +3. I know it's +3 because it's bound to 3 chlorines. Alright, let's look at the zinc at the beginning. How did zinc begin? Not neutral, because it's not an element by itself. Zinc began bound to 2 chlorines. So even if you didn't remember the charge of zinc, you're supposed to remember the charge of zinc, but even if you didn't remember, chlorine has a -1 charge. And if you have 2 chlorines, that means it's got a charge of 2, and zinc's a metal, so it's 2+. Zinc had a 2+ charge at the beginning, and then at the end, why did I write this? Because at the end, zinc is just neutral zinc. Okay, when you see zinc by itself, there is no charge. That is true for all elements. Elements by themselves are not charged. So basically, in the reaction, this is what's happening. You'll notice I picked these out because I looked for the lone element that went to not being a lone element anymore. Chlorine, you can see it's got a charge here. In the end, chlorine still has a charge. Chlorine's a -1. Here, chlorine is still a -1. So because chlorine's charge didn't change, I ignored it during this whole process. It was neither oxidized nor was it reduced. And I picked out the ones where clearly it went from being not charged to having a charge, or from having a charge to having no charge. So, well, iron, clearly what happened to electrons, that's how it becomes positive. Loss of electrons is so that's oxidation. And gain of electrons, that's how you go from a positive to a neutral. That negative charge added onto this will make it turn neutral. So that's reduction. Okay, when you lose positive charge or gain negative charge, that's from adding electrons. And that is going to be a product of reduction. Okay, let's do similar thing for the next one. Now, let's see, I'll need to zoom this out so that you, the viewer, can see the whole equation. There we go. Alright, in fact, let's bring some work paper up into the area so that they can maybe do a little extra scratch work if needed. Okay. Now, let's see, making sure everything's nice and visible up there. Alright. Aluminum plus iron 2 nitrate makes aluminum nitrate and iron. Okay? So, nitrate is -1 and still a -1 here. You're going to assume nitrate never changes its charge. So that leaves aluminum going from neutral to having a charge. Here it's clearly not neutral if it's part of a compound. Here iron's part of a compound, so it definitely has a charge. Here it's by itself, so it definitely doesn't. So I'm going to say aluminum at the beginning, and then at the end, aluminum clearly has a charge. And from the periodic table, you know that that's aluminum with a +3 charge, or if you don't remember that, you can look at this. Each nitrate's a -1, and there's 3 of them, so -3, therefore the aluminum must be a +3. Here, iron starts out with a charge of +2, because it's with 2 nitrates. And then at the end of the equation, iron is by itself. Neutral iron. Well, at the beginning, just to reinforce this concept of how I know what's going on with the electrons, aluminum has a whole bunch more than this, but whatever, for laziness' sake, I'll start with that. Starts out as a neutral, and then in order to be a +3, it would have to lose 3 electrons. Okay, so I'm covering up those 3 minuses to show it the loss of 3 electrons, and that's what would give it 3 extra protons left over, i.e. a charge of +3. So that's loss of electrons, that's oxidation. And then iron, okay, let's look at it for iron. Okay, so now pretend this is iron. At the beginning, iron has a charge of +2. So let's cover up these 2 minuses. Can you see how this now makes a +2, where there's everything balances out except for these 2 pluses at the end? This represents the protons of the iron and the electrons of the iron. Well, if that's iron with a +2 charge, then in order to be neutral, this iron with a +2 charge, okay, that's iron with a +2 right there, would have to gain 1 and 2 electrons in order to become neutral iron with equal numbers of each. So if it gained 2 electrons, gaining an electron is reduction. So the aluminum was oxidized and the iron is reduced. Okay, so that means the aluminum had a 0 oxidation number at the beginning and now has a +3, that's its charge. Iron started with a +2 oxidation number and ended with a 0 because originally had a +2 charge and now ends with a 0. I suppose if I was to do the same for the previous one, this iron started with a 0 and ended up being a +3. This zinc ended up a 0 after originally starting as a +2. Alright, so these others all work the same way. You can work through these other various examples, and honestly what I'd show you would be the same. But let's look at some others that are not exactly the same, as in, like, I've shown you ones where it's mostly metals. Okay, how about one, or the first one had two nonmetals. How about one where you have a mixture of the two? Okay, it may look a little different, but honestly it's the same thing. Okay, I have in mind number 5 right there. I'm preparing the paper so I can... here we go. Do some scratch work. Okay, this blank paper here will allow me to do any extra scratch work I need to in order to make the point. Well, 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 how do we handle this? Once again, I'm going to say neutral aluminum has 0 charge. Neutral Br2 is pure bromine. It is an element. It's going to have a 0 charge, i.e. oxidation number. And then aluminum and bromine together are no longer pure elements. It's a compound. They have a charge. Periodic table tells you aluminum is a +3. Periodic table tells you that bromine is a -1. 3 bromines together balance out the +3 aluminum. Okay, well, what does this mean? This means aluminum went from being, well, just aluminum, neutral aluminum, to aluminum +3. Oops, aluminum +3. And then bromine became bromine with a minus charge. So, how do you become positive? It's by losing electrons. So that's a loss of electrons, which is oxidation. And this one, you become negative by gaining electrons. That's reduction. Because gaining a negative charge means gaining an electron, and gaining an electron is reduction. Okay, so even though the question may look a little different, it still honestly works the same way. Yeah, these all work the same way. Let's see, I suppose I can do one more. Let's see. How about number 12? Actually, how about number 8? I think that's kind of nice because it's the opposite of what some of these other ones are. Okay, number 8. This is a compound. Everything here has a charge. Chlorine, we know from the periodic table, is a -1. Cobalt, well, we can figure that one out because it's from the transition metals. It could be anything. 2 chlorines, so it's going to have a charge of +2. Positive because it's a transition, because it's a metal, and 2 because it's got a charge of 2 to balance out the 2 chlorines. Okay, so here, cobalt, 0 charge, neutral chlorine, 0 charge. So here we're looking at cobalt with a 2+ charge becomes cobalt, that's neutral. Oops, that's not a C. Okay, cobalt, that's neutral. And chlorine with a minus charge becomes chlorine, that's neutral. Well, heck, how does it lose its positive charge? You have to add negatively charged electrons to make this happen. Okay, I suppose I can go back to the little thing I was doing earlier for iron. We can make it a cobalt thing now. So if you have cobalt with a 2+ charge, that means it's got 2 extra positives here, like this. Well, how do you make it neutral? You have to add 2 electrons in order to balance it out and make it into just plain old cobalt. So you had to add 2 electrons in order for this to happen. Adding electrons is reduction. Here, it went from negatively charged to neutral. It lost its negative charge, which means it lost an electron. Leo says, "Gur, loss of electrons is oxidation." Okay. Well, that should take care of that. I suppose the last thing I can point out is just to repeat what I said earlier, especially if you're pressed for time on the test. you'll notice one is oxidized, one is reduced. One is oxidized, one is reduced. One is oxidized, one is reduced. So if you can figure out which two things in the equation are changing their charges, figure out which one oxidizes and you know which one's reduced. Or figure out which one's been reduced and you can tell which, by process of elimination, the other one must have been oxidized, okay? You'll always see one is oxidized and the other is reduced. So if you figure out one, you know what the other one's going to be. It's going to be the opposite. Okay? That might help you on times where you are a little pressed for time, such as on the actual exam itself. Okay, the other ones of these work similarly. Any doubts, consult the internet, or consult a peer, or consult your teacher. Alrighty, happy studies.